This is Algebra 2 with Trig, section 7.5, where we're learning about properties of logarithms. With logarithms, if we're taking the log of a number that can be factored apart, can be broken into two multiples, we can write that with two different logarithms, adding the two together. This is following the same rules as exponents do. When you multiply exponents, when you multiply bases that are the same, you add the exponents. Logarithms are just exponents. So that might help you remember that you should be adding these. So what are we going to do when we divide? So when we're taking the logarithm of a quotient, we will subtract. Now this one's a little bit different. What do we do when we raise a power to the power? What happens to those exponents? We usually multiply them. So this, we're not going to multiply necessarily the m and the n, but we are going to multiply the logarithm by the n. So we bring the n to the front of the logarithm. Still has a base of b to the m. There is no exponent. Exponent's 1 in that case. So for these problems, they're telling us here that the log base 3 of 12 is just about 2.262. So they're essentially being a calculator for us. They're telling us what a number is. And on this side we have log base 3 of 2 is 0.631. So the big question, how could we use those two numbers? The main thing we're noticing is the 12 and the 2. Since the bases are 3's, this base is 3, can I use my 12 and the 2 to equal a 6? How can you use 12 and 2's to make a 6? Since they all have the same base, I can say 12 divided by 2, and I know that that equals 6. Well, this looks like our quotient property we learned from above, where if you're dividing, you can actually write them separate as 12 minus log base 3 of 12 minus log base 3 of 2. So this would become 2.262 minus 0.631. And with your calculator, you'll figure out that that is 1.631. For the next problem, it also has the base of 3. Notice that we're working with 24. How can we use the 12 and the 2 to make a 24? So log base 3 of 12 times 2, that makes 24. So now we have what we're taking a logarithm for, broken into two multiples, kind of like an m and an n. When they're multiplying rather than dividing, when they're multiplying, we can separate logarithm 12 plus logarithm base 3 of 2. Break this into two different problems. And that's going to equal 2.893. Well, what about this third one? Now, it's not a requirement that we use both the 12 and the 2. We just have those at our disposal. So how can we use either the 12 or the 2, or a combination of both, to get to 32? It has to all be through multiplication. We can't use 8 times 4 because we don't know what log base 3 of 8 is. But we do know, or we can work with, 2 to the 5th power. It might be tricky for some to see, but you should start to come familiar with these types of numbers. Now we're going to bring the 5 and bring it in front. And we know that log base 3 of 2 is the value of 0.631, and when we multiply that, we get 3.155. Now we're going to use those same properties, and we're going to condense and expand different problems. Here it's called expanding. When you have a single logarithm and you're going to break it into multiple logarithms, that's called expanding. So the first thing, what's the big item that's here? It looks like a quotient or a division problem, fraction. So we're going to break that apart and say 3x squared minus log base 7 of 5y cubed. What do you see next? A lot of people make the mistake and they bring the 2 all the way in front. You can't bring that in front yet. This is 3 times x squared. So we're going to say log base 7 of 3 plus log base 7 of x squared minus log base 7 of 5 plus log base 7 of y cubed. And when I did that, I put the plus in here. I need to be sure to have parentheses because it's minusing this whole value. That's a very common mistake. People will forget to have the negative. So now I'm going to bring my exponents in front. It's only in front of its own logarithm. So log base 7 of 3 plus 2 times log base 7 of x minus log base 7 of 5 minus, because we're going to distribute that negative to both of these. And that's fully condensed. That's as far as we can take it. Here we know natural log is also a type of logarithm, so the same properties hold true. There's no division, so there's not going to be any subtraction. Natural log of 3 plus natural log of x squared plus natural log of y. Bring the 2 in front. And that's as far as we can go. We have written it with more natural logs. That was our goal. This has 3 different terms inside of it, so that's why we have 3 different logarithms. Okay, you go ahead and try this one. So we're going to say the log of m squared plus the log of n squared. Bring your 2 in front, and we're completed. Here, this is a quotient, so we're going to say log the square root of m minus log n to the fourth. Well, let's think about this. The square root of m. What is the square root of m? Any square root has a fractional exponent. If it's a square, we know that the denominator is a 2. If it's a cube root, we know it's 1/3. So we're going to bring that exponent into the front. And we're done. Now we're going to do something called condensing. We're going to bring it back together. We're going to write it with a single logarithm, only one log. So you might notice that there's a number in front of this logarithm. It's going to go as the exponent. So we have natural log of 8 plus the natural log of 5 squared minus the natural log of 10. We're going to work from left to right. So the natural log of 8, because it's a plus, we're going to multiply whatever this one is, taking the natural log of minus the natural log of 10. Now, because this is a subtraction problem, we're going to say the natural log of 8, 5 squared, divided by 10. Well, what is 8 times 5 squared? What is 8 times 25? That should be 200. So our final answer, we have 200 divided by 10, and our final answer is a natural log of 20. No, not natural log equals 20, but natural log of 20. Here we have two logarithms, so we're going to bring up the value in front. Because it's a subtraction, we write the log. Now notice that we're only writing one log. We're not writing it in the numerator and the denominator. Because of the subtraction, we're going to have a fraction. We're going to put the x squared over y to the fifth. We don't write the log twice. You only do that in the future with the change of base formula. What do you see with the next problem? Bring the 2 as your exponent, bring the half as your exponent. Now, because the bases are the same, and we're adding, we can write the logarithm as x squared times y to the half power. What is y to the half power? That is the square root of y. You want to become familiar with seeing that if it's a half, then it's the square root. If it is the third, then it's the cubed root. Last one. We're going to bring the 2 on top of the y. Working from left to right. So our final answer, the y's are going to reduce. We're going to get natural log of 3 times y. Y squared on top, y to the first on bottom. 2 on top, 1 on bottom, they reduce out. You have 1 left on top with none on bottom.